Hello students, today we are going to solve some problems based on the application of trigonometry exercise 9.1. So here it's question number 5. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building is increases from 30 to 60 degree as he walks towards the building. Find the distance he walked towards the building. So here it's the figure that AO is the height of the building and it is equal to 30 meter. Now the boy is standing here at the point B. From this point B, he is observing the top of the building. That angle of elevation formed is of 30 degree and height of the boy is given 1.5 meter. And he walks towards the building and reaches the point C, and from this point C, when he observes the top of the building again, he get that angle of elevation is 60 degree. We have to find how much distance he traveled towards the building. So let's start. Now here we have the triangle ADC and triangle ADB. Two right triangles are there with the two angle of elevations 30 degree and 60 degree. Now one by one we can solve these two triangles. But before this, what trigonometric ratio we have to use? Let us understand that. Here AO, this is the height, that is we can say in the right angle triangle ADB, this is the perpendicular, okay, and we have to find out the BC, that is the base of this triangle. So that means the relation of perpendicular and base. Which trigonometric ratio gives this relation? Correct, tan theta. So here we use the tan theta in the right triangle ADB as well as in the right triangle ADC. Now one more thing, we have to find out the distance traveled by the boy, that is BC. So let assume that it is x meter. Now use the trigonometric ratio tan theta, that is tan 30 degree in the right triangle ADB, that is perpendicular upon base, and we can write tan 30 degree is AD upon BD, and after putting the value tan 30 is 1 by root 3, we get 1 by root 3 is equal to AD upon BD, and then after by cross multiplication we get BD is equal to AD into root 3. Now again observe this figure, we have to find out the value of AD. Now see, AO, that is equal to 30 degree height of the building, and the boy is standing here. So height of the boy, that is BN, is equal to 1.5 meter, and BN, that is equal to OD, as these two lines are parallel. So OD, this is also equal to 1.5 meter. So for finding the value of AD, we subtract OD from the AO. So here we get AD is equal to AO minus BN, or it is equal to 30 minus 1.5 meter, and value of AD is 28.5. Now put the value BD is equal to AD root 3 here. So we get BD is equal to, that is starting position of the boy from the building, that the distance between the boy and the building, previously it was 28.5 root 3 meter. Now we have to find how much distance he traveled. So let's take the triangle ADC again. In this triangle, tan 60 degree, that is equal to AD upon the base will be changed CD. So AD upon CD. Now as we know that tan 60 degree is root 3. So we get root 3 is equal to AD upon CD. Now put the value of AD here to 28.5. So we get 28.5, and by cross multiplication this root 3 will come out at the place of CD, and CD will goes is equal to right hand side. So AD, that is 28.5 upon root 3 is equal to CD. Now we have the value of CD and also we have the value of BD. So for finding the value of BC, we subtract CD from the distance BD. So let it is distance traveled by the boy, that is equal to BC, and it is denoted by BD minus CD, and values of BD is 28.5 root 3 meter and CD is 28.5 upon root 3 meter. Now put the values. BC will become 28.5 root 3 minus 28.5 upon root 3. Now in these both terms 28.5 is common, so we can take 28.5 common. So inside of the bracket we have the remaining terms root 3 minus 1 by root 3. Now by taking the LCM here, we get 3 minus 1 upon root 3, and after solving this we get 28.5 into 2 by root 3, that is equal to BC. Now as in the place of denominator here is root 3, so we rationalize the denominator and this quantity multiplied and divided by root 3. So we have 28.5 into 2 upon root 3 multiply root 3 upon root 3, and in the place of denominator there are root 3 into root 3, and product of these two root 3 becomes 3, and 28.5 into 2 into root 3, after when we multiply these three terms we get 9.5 into 2 into root 3. As 9.5 we are getting 28.5 cancel out by 3, so we get 9.5 into 2 into root 3, and after multiplying this we get 9.5 into 2 is 19 root 3 meter, and by putting the value of root 3 is 1.732, as we know that the value of root 3 is 1.732. I told that you have to remember the value of root 3. So by putting this value and multiplied it by 19 we get 32.908 meter. Now we can say the distance walked by the boy towards the building is 32.908 meter. From this point he observes the top of the building at an angle of 60 degree. Let's take one more problem. Question number 8. A statue 1.6 meter tall stands on the top of pedestal from a point on the ground. The angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of the top of the pedestal is 45 degree. In this figure we can observe easily. We have to find the height of the pedestal, that this one we have to find out. So by this figure we can identify the right triangle PCA, or we can say here that point A on the ground, that will become P on the ground point. CB is the pedestal, and BA, this is the height of the statue, that is equal to 1.6 meter. And from point P the angle of elevation of the top of the pedestal is 45 degree, and from same point P the angle of elevation of the top of the statue is 60 degree. Now both the angles are here at the same point P, but for the different objects. One of the object is top of the pedestal and one object is top of the statue. So here we have the height of the statue is given, and we have to find out height of the pedestal, that is here again we have in the right angle triangle. In both the right angle triangles we have to find height of the pedestal here. Now here this is the height in the right angle triangle and PC is the base. So height and base, this relation in the trigonometry for the right angle triangle shown by the tan theta. So here we use tan theta. Now for the first triangle BCP, tan 45 degree is perpendicular upon base and it is equal to BC upon PC. So put the value, tan 45 is 1. So we get BC upon PC, that is equal to 1, and by cross multiplication we get BC is equal to PC. Now we assumed that the height of the pedestal, that is BC, is h meter. So in place of PC is equal to h meter we can write. Now again take Next right angle triangle ACP. Now here the angle of elevation is 60 degree. So tan 60 degree is equal to AC upon PC. Now tan 60 degree is root 3 as we know that. So by putting the value we get AC upon PC is equal to root 3. Now as in this figure when we observe the AC, this value or this line segment divides into two parts AB and BC. So in place of AC we can write AB plus BC. So we have AC is the AB plus BC upon PC. This is the value of H. So AB plus BC upon H is equal to root 3. Now this H multiplied with this 3 by cross multiplication we get AB plus BC is equal to root 3 into H. Now here the value of AB, that is the height of the statue, is given 1.6. So we can put the value 1.6 plus BC, we assumed that it is H. So put the value BC is H and it is equal to under root 3 H. Now transpose this H to the right hand side as we have to take the same quantities in one side. So it will become 1.6 is equal to root 3H minus H. Now by right hand side we can take H is common. So we have H is common. So rest of the quantities are root 3 minus 1. And value of H, this root 3 minus H, here right hand side it is in the product form. So when it will goes to the left hand side it will become denominator. So 1.6 divided by root 3 minus 1, that is equal to height of the pedestal. Now root 3 minus 1 is in the place of denominator. So we have to rationalize the denominator, and we know that how to rationalize the denominator. Whatever the quantity in the denominator we have to multiply and divide by the same quantity, but the sign between the terms should be changed. So here root 3 minus 1, that is minus sign is here, so we have to place this sign plus. So root 3 plus 1 upon root 3 plus 1, this multiplied by 1.6 upon root 3 minus 1. Now here 1.6 multiplied by root 3 plus 1, and in the denominator place root 3 minus 1 into root 3 plus 1. Now remember this one is an identity, a minus b into a plus b. So it will become correct, a square minus b square. Now in place of a, that is root 3, in place of b, that is 1. So we can say root 3 square minus 1 square, and 1 square that we can write 1. Now root 3 square, that is 3. So we get 1.6 into root 3 plus 1 upon 3 minus 1, and denominator becomes 2. So we have height of the pedestal is 1.6 into root 3 plus 1 upon 2. And now this 2 when divides 1.6 we get 0.8 into root 3 plus 1. Now again put here root 3 is 1.732. By putting this we get H is equal to 0.8 into 1.732 plus 1. Now this addition is 2.732, and this multiplied by 0.8 we get H is equal to 1.3856 meter. So here we can say the height of the pedestal is 1.3856 meter. Now remember, when you are getting the height is 0.8 into root 3 plus 1 meter, this is also the height, and we can leave the problem, the solution here up to here only. But by putting the value of root 3 we get exact value of the value of the pedestal in terms of meter. So we are putting the value here root 3. So there is no harm when you are leaving the solution H is equal to 0.8 into root 3 plus 1, or further you are solving and getting the value H is 1.3856. So both the answers are correct, 0.8 into root 3 plus 1 or it is 1.3856. So we can say height of the pedestal is 1.3856 meter.